Hello, my name is Sander and I'm a technical trainer based in Sydney, Australia. The topic we will be discussing is security, which is an important topic for all customers. Today we will show you how to create secure environments by utilising AWS security services, and we will also learn about the AWS Shared Responsibility model. You can access these services directly through the console, CLI, SDK or APIs. The first aspect of security we will focus on is securing your infrastructure. Security is a top priority in AWS. The AWS infrastructure has been architected to be one of the most flexible and secure cloud computing environments available today. It is designed to provide a scalable, highly reliable platform that enables customers to deploy applications and data quickly and securely. The security services AWS offers allow customers to monitor their environment and allow security issues to be rectified in an automated manner by utilizing API integration services. Services such as AWS Config can monitor AWS resources to track configuration changes and can automatically remediate its findings to improve upon the security posture of your environment. For example, if an administrator allows SSH to the world in a security group, AWS Config can remediate this automatically. The platform itself has been built with high availability in mind to eliminate single points of failure. The AWS Global Infrastructure is highly accredited, and we will discuss later in this module the industry standard compliance programs AWS is compliant with. Examining the AWS Cloud, you'll see that the same security isolations are employed as would be found in a traditional data center. These include physical data center security, separation of the network, isolation of the server hardware, and isolation of storage. We have a shared responsibility model with the customer. AWS manages and controls the components from the host operating system and virtualization layer down to the physical security of the facilities in which the services operate. This is what we call security of the cloud. In the previous slide, we talked about how AWS is responsible for security of the cloud. The customer is responsible for security in the cloud. What this means is customers are responsible for building secure applications. We provide a wide variety of best practices, documents, encryption tools, and other guidance our customers can leverage in delivering application-level security measures. In addition, AWS partners offer hundreds of tools and features to help customers to meet their security objectives, ranging from network security, configuration management, access control, and data encryption. For example, if a customer has a security requirement to implement encryption at rest on their EBS volumes, customers are responsible for configuring EBS to use KMS encryption keys to meet this requirement. If we put the two parts we have just discussed together, security of the cloud and security in the cloud, this forms the AWS Shared Responsibility model. AWS operates under this model. An easy way to remember how this works is to think of it like this. Anything you cannot see, touch, or change is AWS's responsibility, security of the cloud. For example, if customers do not have access to open our EBS storage racks, therefore the physical and logical security of EBS belongs to AWS under the shared responsibility model. Anything a customer can see, touch, or change is the customer's area of responsibility, security in the cloud. For example, customers have full access to the EC2 instance operating system, so the customer is responsible for patching vulnerabilities within the OS. AWS has a full suite of security services that customers can leverage in their environments. The three security services we will focus on today are AWS IAM, Identity and Access Management, Amazon Inspector, and AWS Shield. When it comes to the two A's, authentication and authorization within an AWS account, the service which manages this is IAM, which we will discuss in further detail. IAM is a service which controls who can authenticate to an AWS account. This can be done using a number of options within the IAM console. The first option is IAM users. IAM users can be created, and we can authorize what actions an IAM user can perform inside the account. We can also create IAM groups and place the IAM users inside the groups. We can then authorize what actions the group can perform inside the account. This removes some of the administrative burden of having to manage authorization at an individual IAM user level. The last option which can be used are IAM roles, and we can authorize what actions the IAM role can take inside the AWS account. IAM roles are unique in that they provide temporary credentials that can be used to access AWS resources. The IAM role can be assumed by IAM users and AWS services such as EC2 or Lambda. This means we do not need to hard code our credentials inside our application code or on the EC2 instance itself. IAM roles can also be used by other AWS accounts for cross-account access and federated identities to allow existing identities from our corporate Active Directory to access AWS resources. IAM users can access AWS via three methods. The first is AWS CLI, command line interface, typically used by system administrators. AWS SDK, software development kit, typically used by developers. And the AWS Management Console, used when customers prefer to use a simple GUI. Each one of these access methods requires an IAM user to be authenticated before they can access the AWS resources. After the IAM user authenticates to AWS, how do we control what they have access to? This is done via an IAM policy. An IAM policy is a document written in JSON which determines which services and what access to those services an IAM user has. As mentioned earlier, an IAM role can be assumed by IAM users, AWS services, other AWS accounts, and federated identities. The IAM policy is assigned to an IAM role which determines what the role does or does not have access to inside the AWS account. In this scenario, the application on the EC2 instance wants to access the S3 bucket. By default, the EC2 instance does not have credentials to access the S3 bucket, so access is denied. First, we create an IAM policy or use a template policy to determine what we want the EC2 instance to have access to. After the policy is created, we then create an IAM role. Next, we associate the IAM role directly to the EC2 instance. After we do this, the EC2 instance can then access the S3 bucket, and the IAM policy determines which actions the EC2 instance can take on the S3 resource. Through the whole process, the EC2 instance does not have any credentials hard-coded, and the IAM role ensures the temporary credentials assigned to the EC2 instance are rotated on a regular basis. When a new AWS account is created, you are given a root user ID. The root user ID is an email address. If you are logging in with your AWS account with your email address, you are logging in with the root credentials. The root account cannot be controlled by IAM. It has full access to the entire account, and we recommend not using it for day-to-day actions. The recommended actions are: delete the root access keys. Note the root account cannot be deleted, but the access keys can. Enable multi-factor authentication on the root account. We support both software and hardware tokens. Create an IAM user. Grant access to the IAM user. Admin access can be granted if required, but the principle of least privilege should be applied. Interact with AWS using your IAM user credentials. In this demo, we will visually explain the IAM concepts using a virtual blackboard. The root account is the first account created and has full access to the AWS account. If you are logging in with an email address, you are logging in with the root account. We recommend the following best practices to secure the root account. Enable a strong password, enable multi-factor authentication, IAM supports hardware and software tokens, and delete the root access keys. At the heart of IAM are IAM policies. There are two types of IAM policies, which are AWS managed and customer managed. An IAM policy specifies what a principal has access to or has been denied access to. IAM policies can be assigned to different principals later. One type of principal is an IAM user. An IAM user can authenticate to AWS account in two ways: via the AWS console using a username and password, or via access keys using the AWS SDKs or CLI. One or more IAM policies can be applied to the user. Assigning policies directly to the users can be an administrative burden. IAM also supports groups. Groups can be created based on roles users perform. Users can be added to the groups, and IAM policies can be assigned directly to the group rather than each user. This makes administration a lot easier. Another type of principal is an IAM role. Think of an IAM role as a hard hat that other AWS services can put on. Our EC2 instance is going to put on this hard hat or assume this role. By assuming a role, the EC2 instance is granted access as per the IAM policy assigned to the role. In this example, the IAM policy provides read and write access to the S3 bucket. Behind the scenes, there is a service called STS, Security Token Service, which powers IAM roles. This service issues temporary credentials, rotates the temporary credentials, and assigns a TTL for the temp credentials. Here is a summary of best practices we recommend when it comes to security in IAM. I have discussed some of these best practices already. I will pick out a few to highlight. Use the principle of least privilege. Only grant enough access for users to complete their tasks. Do not assign anything more or less. Whenever possible, use IAM roles so we don't have to hard code any credentials in our instances or in our application code. Rotate your credentials. IAM supports password policy changes and access keys can also be recreated. Lastly, monitor activity in your account. Use services like CloudTrail to keep track of all the API calls made in your account and store them in an S3 bucket for traceability. Performing threat assessments inside an environment is no easy task. Most tools are costly. Also, configuration and maintenance takes time. Is there an AWS managed service that can assist and perform a lot of the heavy lifting for customers? Amazon Inspector can help with performing threat assessments in your AWS environment. It automatically assesses applications for vulnerabilities or deviation from best practices. After performing the analysis, Inspector will produce a detailed security finding report, which is accessible from the AWS Inspector console or via an API. Amazon Inspector includes a knowledge base of hundreds of rules mapped to common security best practices, and these rules are regularly updated by AWS security researchers. Inspector leverages an agent installed inside the EC2 instance to perform the threat assessment. This makes it easy to build as part of your DevOps deployment process. Here is an example of Inspector findings after a scan. Findings are potential security threats. Each finding will contain a detailed description of the security issue and recommendations for resolution. Some of the details provided include name of EC2 instance where the finding was registered, name of template used to provide the finding, assessment start and end time, severity of the finding and remediation steps. Here is an example of a finding and remediation actions. As you can see, Inspector details the finding and then provides detailed remediation actions. In this particular case, it is recommending to prevent root logins over SSH. In this section, we will discuss the AWS service which protects against distributed denial of service attacks. When a DDoS attack occurs, an attacker is trying to flood your website to cause an outage. The attacker typically uses multiple sources, such as compromised computers infected with malware from various locations around the world. The attacker can attempt to exhaust compute or bandwidth resources to your website to take it down or make it unavailable to legitimate users trying to access your website. DDoS mitigation is a complex task. It is not something that can be quickly set up on-prem. There are challenges around provisioning enough bandwidth. It may require re-architecting existing solutions and can be costly to implement and maintain. AWS Shield provides DDoS protection out of the box for customers as a managed service. This service is always on and is free when customers use services such as ELBs, CloudFront, and API Gateway. It does not require any re-architecting to existing applications and leverages our highly available, secure global infrastructure. As mentioned earlier, Shield Standard is a free service that protects all customers, provided they are using services like ELB, CloudFront, and API Gateway. With Shield Advanced, there is a cost associated, but there are a number of benefits to customers, such as specialized support from a dedicated DDoS response team and cost protection. With AWS Shield Advanced, customers have access to a DDoS response team 24/7 that can assist customers when they are under a DDoS attack. With cost protection, any cost a customer incurs due to a DDoS attack, for example scaling out, AWS will cover that cost. In the next section, we will look at assurance programs that AWS is compliant with. Here is a sample of the assurance programs that AWS is compliant with. These are industry standard programs, and some customers may already be familiar with them, such as ISO, SOC, IRAP, and so on. Customers can access the AWS compliance page to get further details on each program, and how AWS is compliant. To assist customers to achieve compliance, AWS ensures the underlying platform is compliant and provides proof of compliance via attestations of compliance provided by third-party companies. Let's take PCI, Payment Card Industry Standard, as an example. Many AWS services are PCI compliant, but customers are responsible for making sure their application code is PCI compliant. AWS and customers share the responsibility when it comes to compliance as well. Customers can navigate to the AWS Compliance Programs page to see the various programs AWS is compliant with. Scrolling through the page, there are global programs as well as country and region-specific programs. By clicking on one of the programs, we can access more information. For example, let's have a quick look at PCI DDoS Level 1. But what if we need to provide an artifact to an auditor to prove that AWS is PCI compliant? Do we need to engage AWS to obtain the necessary evidence? This can be resolved by the customer directly via the AWS console. Customers can access the AWS Artifact service. This service allows customers to download PCI attestation of compliance reports where reputable third-party companies have verified AWS as PCI compliant. This document can then be provided to the auditors. Remember, AWS operates under the shared responsibility model. Customers are responsible for owning their own certifications. AWS can assist in two ways, with infrastructure compliance and AWS services compliance. Customers are responsible for reviewing, designing, identifying, and verifying they are compliant with their requirements.